let's look at chemical reactions. So we learned all about these different elements and atoms, and so how these elements exist with their characteristics. You might imagine that since they share these electrons on their valence shell, that they might be able to react with each other, and that is indeed what happens. And so when we have these bonds being formed between elements, or when they're rearranged, switched out, or when they're broken, we have what we call a chemical reaction. So theoretically, all of our chemical reactions are reversible. You form a double bond between an oxygen and a carbon, you can break that double bond, okay, and vice versa. Chemical equilibrium is known if, or is considered what happens if there is no dominance of a forward or reverse reaction. So you don't have more carbon and oxygen double bonds forming than being broken, and you don't have more being broken than there are being formed. If that were the case, that would be considered chemical equilibrium. These reactions are absolutely essential, and they're most of the time, some of them are irreversible because of energy requirements to go back and forth between forming bonds and breaking bonds. And also in the body, a lot of times when a bond is broken, some of the molecules or the products of the reaction might be taken away, and then you don't have it there anymore to continue the reaction. There are three main types of reaction. We can synthesize or combine and usually make bonds. That's also known as anabolic reaction. We can decompose or have a decomposition reaction. That's known as catabolic, when bonds are being broken. And then we have exchange reactions, where somebody might break a bond with someone else, but then they're going to go form a bond with someone else. You break up with one girlfriend to go have another relationship with another girlfriend, something like that. So an exchange, exchanging out your girlfriend. So let's look at each of these reactions in turn. In an anabolic reaction, again, we're generating. It's a synthesis reaction. You're going to take molecule A, and it's going to form a bond with molecule B, and you're going to get a product. We call this a product. Product AB. And so these smaller particles bond together to form larger, more complex molecules. This always involves the formation of a bond. One example we have here on the right are amino acids. So we join amino acids together by bonds. They're called peptide bonds to form a protein. All right? So amino acids form bonds together to form a protein. These are also known as endergonic reactions, and that means that when the bond is formed, they've got potential energy in these bonds. Remember when we talked about the different kinetic and potential energy? It's potential energy because when these bonds are broken, energy is released. It becomes kinetic. So these products have more energy in them than the reactants did, which also means it's endothermic. It takes in heat. Now, if we look at decomposition reactions, these are known as catabolic reactions, a breakdown. So we have a breaking of bonds. AB is going to turn into A and B separate. So these bonds are broken. It gives you products that are less complex. An example of this is going to be glycogen. Glycogen is a lot of glucose molecules bound together. And so if we go in and break those bonds, then we're going to have lots of free-floating glucose molecules. What this means is when we break the bonds, we're going to release energy. And so it's an exergonic reaction, unlike the storage or preserving of energy that we see in the anabolic reactions. And that also means these are exothermic. So in a decomposition reaction or a catabolic reaction, we're giving off heat. It's exothermic. And it's the opposite of those synthesis reactions. And then finally, we have the exchange reactions, in which they can also be called displacement reactions, but we basically are exchanging one bond and forming another one. So A and B have a bond, but I don't know, A sees C and says, yep, okay, bye B, I'm going to join C. All right? And so the bonds are made and broken. And so that's why it can also be called a displacement reaction. An example is when ATP transfers one of its phosphate groups to glucose to give you glucose phosphate. And at the same time, adenosine triphosphate, tri meaning 3 phosphate groups, turns into diphosphate. So it gives away a phosphate group to glucose.